Okay, so in the last video, I showed you how my desk setup looks like. There has been a slight change. I haven't uploaded a video in about a month, and the reason being everything behind me, I moved to a totally new place, moved cross country, and the desk setup is being rebuilt completely. I know the title of this video says network switch, and I'm gonna get to it, but I'm gonna give you a quick update on what's gonna happen. The desk setup that I had before, I had no server rack, I had some basic equipment. It really worked. What's gonna happen now is soon we're gonna have a server rack, a 3D printer. So anything that goes into the server rack and we need to create custom mounts, everything's gonna be custom built for the server rack for the entire server. So stay tuned for that. That's gonna be coming up in the next video. We're gonna have a server rack hopefully, and then by the beginning of next month, I'll have a 3D printer and I'll be learning how to create models, how to print stuff, and it's going to be a whole ordeal, and I'm going to share my whole experience with you. For this video specifically, what we're looking at is a unified PoE light switch. And what this means is, in the previous video, you saw that I have a networking switch. It's from Netgear. You can see on the screen, it's pretty inexpensive. It has 8 ports. 1 port takes the internet in, and 7 ports take the internet out to all the devices that you're trying to connect. But as you saw from the last video, I have so many Raspberry Pis, I have an Nvidia device, and I have other devices in my home, and it just gets really crowded. And I filled up those 7 ports really quick. And now moving to this new place, the router that I got from Verizon, that only has 2 LAN ports, I believe a third one, but I haven't tested how that works. So only 2 means, and with my previous router, I actually had 4. So if I had to connect my PlayStation with Ethernet, or if I had to connect like an Apple TV, all of that could be done just through the router, because it had like 4 ports plus the 7 that were on my network switch. But the server is growing and it's a really good thing. So I had to get a new network switch, and it had to have a lot more ports than I have had in the Netgear switch. So this has 16 ports. In these 16 ports, as always, one of them is always the one that gets the internet in, and the rest of them are what takes the internet out to all of your other devices. So this switch is going to go into the new server rack that's going to be coming in. It's going to provide internet to all of the Raspberry Pis, the Nvidia devices, any additional device that we connect into the server is going to get internet from this. As you can see from the video, there's a left half and the right. So the number one thing why we got the network switch is we needed a lot more ports than the Netgear one. And the second biggest thing is it is PoE. PoE means power over Ethernet. If you don't know, Ethernet ports have always been all about carrying internet from one point to the other. But with the advances in technology, PoE has gotten way cheaper than before, and what it allows you to do is you can connect one Ethernet cable and connect it to another device, and it can give it internet and power. So what the utility of that is, if you have a lot of like security cameras, security devices, and they all need internet, like wired internet is the most reliable one. So you can just connect one Ethernet port and take that cable all the way to wherever your external camera is and connect that Ethernet port, and it provides the power and it provides internet, and really stable internet. And it can do that for the 7 ports that you see on the left. What I am going to be using it for is specifically powering Raspberry Pis. A new Raspberry Pi 5 can take up to 27 watts of power at peak power, but on idle it takes like 2 to 3 watts. And if you're doing something like normal, not really power intensive, it maybe draws like 9 watts. And if a port can provide 10 watts from the network switch, then I don't have to find a port on my power brick to find one power for the Raspberry Pi. Second, that is a cable that has to still be routed to the entire server rack to the Raspberry Pi. And that's a whole hassle. If you have multiple Raspberry Pis, you just have to do so much cabling. It's kind of insane on top of the other devices that are in your server rack. And one of the most important things that this thing does, why it costs the $200 compared to the $18 that the Netgear one costs, is that it can divide your network into multiple sub networks. So I have a lot of devices like a robo vacuum and other devices that are more IoT devices, and I don't want them to be on my main network because I don't know what their security protocols are. Like, they can be hacked, and if they're already attached to my main Wi-Fi where my phone is connected, my MacBook, family's devices are connected, and they open like banking apps and whatever, you don't want them to be on the same network as these IoT devices. So you can create sub networks. So one is for your primary main home devices and your personal devices, and the other ones will be like your IoT devices, like your robo vacuums, 8-sleep mattress or whatever you have. So that's like a really good security feature and that you can manage using this network switch that the unmanaged network switch do not have. So I think that's what the main use case is. I'm not going to be using all the ports as of right now, but it also gives me the expandability in the future and that I can add more devices pretty easily to this entire server rack that I'm going to be having and not have to worry about that I'm running out of ports like I did before. So I hope you enjoyed it. I hope this was informative in some sort of way. If you have questions, let me know in the comments, and soon, hopefully next week, we'll have a server rack, and I would love to show you how exactly I go about it and some of the choices that I make. Till then.